Thanks, Jesse. Thanks for everyone for your interest. So my name is Xiao, and I'm a PhD student in Columbia University, and this is a joint work with Maxime from McGill University and my advisor, Adam. So the background of this project is that differential pricing has become very common in practice, but on the other hand, the US Civil Rights Act makes it illegal to discriminate against protected attributes such as race, gender, age, marital status, all these kind of protected features. However, price discrimination practices has been shown to not comply. For example, there's a famous phenomenon called pink tax, which means that female customers generally receive a higher price in many industries like hair salon. And also there has been research showing that African-American has received a higher price for Uber and also higher loan interest rate. So as you can see, discriminatory pricing has indeed received a lot of moral and legal concerns. But on the other hand, there are no clear guidance on how to ensure a fair pricing strategy. So this is the focus of our paper. So in this project, we want to answer two questions. The first one is how do we model fairness in the context of pricing? And here we provide a framework for doing that, which is quite different from the machine learning fairness models. And second, we want to focus on the question like, what is the impact of adding fairness constraints to the social welfare? So let me briefly introduce our model here. We assume there's a monopolist who is selling one product to two groups, group 0 and group 1. And we assume that the unit cost of this product is C, okay? So for each group I, we assume there's a population size DI. And the price charged to this group is simply PI. And for customers within this group, we assume they have random valuation VI, which is sampled from a distribution FI. And the market share of this group is simply F bar I PI, okay? And we use the quasi-linear surplus, which is VI, the positive part of VI minus PI, okay? So the profit of group I is simply the population size D times the unit profit P minus C times the market share F bar I PI, okay? And finally, we will use PI star to denote the optimal price for group I without any fairness constraints. So in the paper, we considered 4 definitions of fairness, which we call them fairness in price, demand, surplus, and no purchase valuations. So fairness in price means that we want the price received by the two groups to be similar or even equal, because this is the most straightforward definition for fairness in pricing, right? The second one, fairness in demand, means that we want the market share of the two groups to be similar or equal. So one motivating example here is the college admission. So you can see that in many cases, we are offering fellowships to those in minority groups or those who are in need, because by doing so, we can make sure that both groups has equal access to a good education. Surplus fairness means that we want the average surplus for both groups to be similar or equal. This is because surplus is a measure of happiness, and we want both groups to be similar happy. And finally, no purchase valuation is something we propose and something new. So basically, no purchase valuation means the average valuation for those who cannot afford the product. So obviously, those who cannot afford the product are also victims of differential pricing, and we want to take them into account. But their surplus is always 0. So one way to do that is that their valuation is always positive. So we will use their valuation to be the measure of unhappiness. So basically, the no purchase valuation fairness measures and want to make sure that both groups is equally unhappy. Okay. So with these 4 definitions, we use a single variable alpha to measure the fairness level. For example, when alpha equals to 0, there's no fairness. And if we are focusing on price fairness, that means that we don't have any constraints on price. And we use alpha equals to 1 to mean perfect fairness. And in that case, we need the price to be totally equal for the two groups. And for any alpha between 0 and 1, we simply assume that there's a fairness constraint makes such that the price difference of the two groups has to be less than 1 minus alpha times the initial difference. And the similar constraints for the other fairness measures here. Okay. So with this framework, our first question is, can we achieve perfect fairness simultaneously? The answer is actually negative. That is, if the two groups has different mean valuation, then it is impossible to achieve perfect fairness in price, demand, surplus, and no purchase valuation all simultaneously. But on the other hand, this is a necessary condition. So equal mean valuation is a necessary condition for perfect fairness, but it's not sufficient. This is because, let's say, for example, for group 0, the valuation is exponential with mean 1. And for group 1, the valuation is uniform between 0 and 2. So these two groups has the same mean valuation. But in this case, only perfect fairness in price and demand can be achieved simultaneously. And for any other pairs of fairness, they could only be achieved with 0 price. And this is meaningless. So due to the hardness of achieving multiple fairness criteria, we will consider them separately and up to a certain level of alpha. So in this case, the seller still wants to optimize their profit. They still tries to maximize it, but subject to a fairness constraint. But on the other hand, the regulator or the society wants to see what happens to the social welfare, to see the implication to the whole society. Okay, so this is the implicit thing that we want to investigate. So in the paper, we give a full characterization for linear model because it's kind of simple and tractable. But however, I want to mention that this problem is not convex. Actually, the solution is non-linear in general. So actually, this is an example of how the price changes with alpha, the fairness level, and under 4 fairness constraints. And you can see that actually under price fairness, surplus fairness, and no purchase valuation fairness, the price changes are not linear. So the problem is not that trivial. So for time reasons, let's focus on the implication on the social welfares. So for price fairness, we find that when alpha is small, that is when we only have a little fairness, social welfare is increasing with alpha. But on the other hand, when alpha is large, the seller may give up the low valuation group because by doing so, he can set a high price for the high valuation group. And such practices will lead to a lose-lose situation between the seller and the customers. So to restrict fairness in price may lead to a lose-lose situation. For demand fairness, we show that the social welfare decreases monotonically with alpha. So this is not very significant in this figure, but we show that this is something strict, and it is always happen. For surplus fairness, we show that social welfare is always lower than the unconstrained case. So that means surplus fairness also reduces the social welfare. And finally, for no purchase valuation fairness, we show that social welfare always increases monotonically with the alpha. So this is quite different from price fairness because for now, the seller cannot give up the low valuation group to satisfy the fairness constraints because for linear demand, you cannot set the price to be super high. And by doing so, you cannot improve the no purchase valuation fairness. So that's the intuition behind the benefits of no purchase valuation fairness. So in the paper, we also considered several extensions like what if we have multiple groups with linear demand? What happens if we add one unprotected features? And we also did extensive numerical experiment for nonlinear common demand models. And we find that many of our findings are robust in different cases. So if you're interested, please check our paper. So to summarize, we find that different fairness constraints cannot coexist in general in the context of differential pricing. And we find that for several cases, a little price fairness is beneficial, but too much of it may lead to a lose-lose situation between the seller and the customer. And we find that demand fairness always leads to lose-lose situations in most cases. And surplus fairness reduces social welfare in all the cases we have discussed. And finally, a little no purchase valuation fairness is beneficial in most cases, and it is the best in linear demand in terms of social welfare. So I will stop here. Thank you for your interest, and the paper is online. And I'll be happy to answer any questions you may have.